Previously, we had worked out, estimated a reaction function for the Greenspan period, or approximately the Greenspan period, from Orphanides. We noted that the conventional Taylor rule, as set out by Taylor in 1993, can be summarized as a reaction function where the constant in the reaction function was 1. The B1, the coefficient on inflation, would be 1.5, and the coefficient on the output gap, or in this instance growth gap, is 0.5. When we run a Lin-est estimation, which is an ordinarily squared estimation, where the Fed funds is the dependent variable and inflation and growth gap here constitute the independent variables, the coefficient estimates are not dissimilar to the original Taylor rule. What actually is different is the magnitude of the constant, and we can have a look at that when we add to our analysis. But if we take this Lin-est estimation and take the dates in question, so if we took from last quarter 1987, and I think we went up to, well, last quarter 2006, so okay, not strictly the Greenspan period, but close enough. So the last quarter 1987 would stem from here, and we're going up to 2006 to the last quarter of 2006. Okay, so let's just take that, copy, and put it into a new workbook. So file, and we're going to do a new workbook, so new, and we'll paste special, let's just paste and bring across and insert, and going back to the original spreadsheet, we would have had Fed funds, inflation, and GG, growth gap. So okay, we could copy, go back to our new file, a new workbook, and just paste, and we'll just call this, for convenience, Fed funds, inflation, and growth gap. Okay, and it's from 87, last quarter, 2006, last quarter. Let's take out this column, and we'll say file, save as Greenspan. So we'll say Greenspan data Q4, so 9872006, and important here is to save it as a CSV file, and because it's a Microsoft, because of working Windows, we'll go with this option and save. Okay, so that file is now there. Now we want to run. Let's have a look at the estimation that we had here. It was the Greenspan period, and these are the coefficients and standard errors, t-statistics, and so on. What we could do is run the same regression again, using this as our model. Fed funds is equal to constant plus B1 times inflation plus B2 times the growth gap, and just observe the estimates for these coefficients, the constant and the parameter coefficients. Okay, so we might go into RStudio and open it up, and it's opening up relatively fast. And let's put in a new file. So file, okay, so file, new file, RScript, and we want to take, what we want is to estimate our regression using, implement the Taylor rule estimation. Okay, so I have some code, and we can take that in from tutorials, Taylor rule, and Greenspan reaction function. And this is just some code that I took from Annie Kachova's Econometrics Academy, and slightly amended here to take into account that I want to estimate a Taylor rule. So if you want to have a look at her video clips, that's her channel on YouTube. And I have just amended, so okay, let's just examine a little bit how I got this file. Okay, so typically what I would do is I would go to the folder in question. So this is the CSV, sorry, this is the CSV file here. It's comma separated. Okay, so we get the properties, and we look at the location of that file, keeping in mind what the name of the file is, Greenspan data 1987-2006. Okay, so let's put this, just read this, paste this in, and change the backslash to forward slashes. Okay, so that RStudio is able to read the location correctly. And okay, last part here is the name of the file, Greenspan data 1987-2006. Okay, so just bring redimension to see. Okay, I think that's correct. Maybe we could try to save. Okay, and we'll save this one here, and then replace. Okay, so okay, first of all, can we get the data in? Okay, so let's run and attach the data, and it seems to have attached, and I've called it my data Taylor. Okay, so let's just inspect that, and yes, it's 77 entries. That looks about right, and the values look okay. So we can check against. So here we have 6.92, 4.4, and 0.725, and we have the same here. Okay, so looks okay. Go back to our RScript. Okay, we want to attach our link variables to so the Fed funds, we're going to say, is Y, which is the dependent variable. Inflation is a single variable, we'll call that X1, and then we have this matrix, and we're going to call that X. Okay, so let's run and run again, and summary of Y, so summary of the Fed funds, and we've minimum value, medium, maximum value for the Fed funds rate over that period, 9.73. The minimum value was 1. And now we take the summary for X, and X was, well, two variables, inflation and the growth gap. Again, the lowest value for the growth gap was 4.5, but negative, and so on. So that's easy to follow. We can do a correlation coefficient. We could plot maybe x1, keep in mind, is inflation, and that's plotted against y, which is the Fed funds rate, and that's an interesting graph. The shape isn't completely linear. Okay, so now let's run the regression, and keep in mind we're regressing inflation, the growth gap, onto the Fed funds rate, which is y. So let's run. Let's hit run. OLS. Let's get a summary of the output, and you can see here we have again. This is an intercepted constant, and we're regressing inflation. Okay, and we've slightly different values to what we had seen before. So if we copy here and go into our output and just paste, okay, you can see that there's a difference. The constant and x1 are different, although interestingly, again, keep in mind x1 is just inflation, so we've, if you like, we've estimated inflation, a simplified Taylor rule that ignores the output gap, but the coefficient on inflation is in excess of 1, and the intercept is higher here than what we have here. Okay, and r squared in the region of 42. Okay, so let's go back into our regression again, and this time, okay, let's copy the same regression, okay, and we'll bring it down below, perhaps down here, and paste. So this is from line 43, and we're going to say OLS reg, and I'm going to take out the ones, and when I remove 1 here, this now is referring back to what? It's referring back to the fact that it's both GG and I being regressed onto the Fed funds rate. So come back down to line 43, and let's take away the 1. Let's take away the 1 again, and let's take away the 1. Okay, so let's try this. Let's run and get the summary of the output, and we have, okay, let's just copy this, copy, go back into our spreadsheet, and let's take away this and just paste and make the comparison. And what we observe is that the coefficients here, now slight difference, 1504037 r squared. So why the difference? Not completely clear. One possibility here is how we copy and paste our values into the CSV file, CSV, and that I can illustrate perhaps in the next video clip. But again, the values are almost the same, right? The values are almost the same. The standard errors, the constant, just tiny differences. And in the next video, I'll try to see why those differences occur and how we can improve the synchronization between both. Okay, so I'll leave it there.